ChemStars, welcome back again to today's tutorials. Okay, now we are still on comprehensive definitions of a mole. Let's continue with our questions. What mass of ethane contains the same number of molecules as 3.2 grams of sulfur 4 oxide? Ethane is C2H6, sulfur 4 oxide, that is SO2. Okay, beautiful. What mass of ethane contains the same number of molecules as 3.2 grams of sulfur 4 oxide? What mass of ethane? They are asking you. They did not give you the mass of ethane, which has the same number of molecules. It means that the number of moles of ethane and the one of sulfur 4 oxide is the same. Now, as 3.2 grams of sulfur, that means the mass of the sulfur that has the same number of moles with that of ethane. So we'll start from simple to complex, from known to the unknown. And what is the known here? Calculating the moles of 3.2 grams of sulfur 4 oxide. What is the mole? So we'll say solution. Mole of sulfur 4 oxide is equals mass over molar mass. What is the mass of sulfur 4 oxide given? 3.2, okay? What is the molar mass? The molar mass of sulfur 4 oxide, you calculate for it, okay? 32 plus 16 times 2, okay? This is equals 3.2 over 32 is here, 32 is here. This is 64. This is how to calculate the molar mass. Check the previous tutorials, okay, so that you understand how we did this. Now, the mole of sulfur 4 oxide will be 3.2 divided by 64. This is equals to 0.05 moles. Beautiful. This is the mole of sulfur 4 oxide. That means is this 0.5 moles that is same number of molecule as ethane. It means that the number of ethane, the moles in ethane is still 0.05 moles. So if ethane is equals 0.05 moles and molar mass is equals C2H6. The same method we do here, you will still do it here. Carbon is 12, hydrogen is 1. Are you with me? So this is 12 times 2, and this one is 6 times 1. When you solve everything, you'll be having 30 grams per mole. This is the molar mass of ethane, okay? Now, we have gotten the moles, we have gotten the molar mass. Are you seeing it? We are now back to the question. What mass of ethane? What is the mass? We know the simple relationship. Mole is equals mass over molar mass. Look at the one we are asked to find, the mass. So how do we get the mass? We simply say mass is equals mole times molar mass. This is equals 0.05 times 30. By the time you multiply this, you now have mass of ethane is equals 1.5 grams. Beautiful. That is the answer. Navigate your ways and solve this thing from known to the unknown, from simple to complex. Are you with me? Good. Now let's go back and solve the question number 2. I hope to manage this place and solve this question. How many molecules of hydrogen gas would be produced? How many what? Molecules. Remember, you cannot solve for molecules, number of molecules. That is the Avogadro's number, the elementary particles, without first of all calculating for the moles. Anytime you are asked to find the number of molecules, first of all get the mole. Are you with me? Good. So, how many molecules of hydrogen gas will be produced when 5.4 grams of aluminium reacts completely according to the equation? When you react aluminium with HCl, you have aluminium chloride and hydrogen gas will be given off. They are asking you calculate this one, the number of moles of this one, when 5.4 grams of this one is reacted completely with HCl. So all these grammar, we're going to write them out so that we'll be able to understand it, okay? So number 2, solution. So what do we have here? 5.4 grams of aluminum. Please, let's solve from simple to complex. We'll say mole of aluminum is equals 5.4 divided by, what is the atomic mass of aluminum? 27, okay? 27. Now, mole of aluminum is equals 5.4 divided by the 7 is what? 0.2 moles. We have gotten the moles of aluminum, okay? Now, we can use this mole to establish the stoichiometry, that is the relationship between aluminum and hydrogen. Go back to this equation. How many moles of aluminum is reacted? 2 moles. How many moles of hydrogen did this produce? 3 moles. Are you with me? So let's establish this relationship. 2 moles of aluminum yielded 3 moles of hydrogen gas. This is the relationship. Now, what mole did we calculate? 0.2. Are you with me? Therefore, 0.2 moles of aluminum will yield, are you with me? Good. So this is just the relationship. We yield X mole of hydrogen gas. So what do we do to get our X mole? So we simply multiply everything. Let's write down this thing shortly here so that you understand what to have here. 2 moles of aluminum use 3 moles. This is 2 moles is equals to 3 moles of hydrogen. This is what we have here. Are you with me? Now, 0.2 moles of aluminum. 0.2 moles of aluminum is equals to X mole. This is what we have written here. So that we simply do our simple cross and multiplication. We say 0.2 times 3 divided by 2 will give us our X, okay? So this implies 0.2 times 3 over 2. By the time you multiply this, 0.2 times 3, you have 0.6 divided by what? 2. This is equals to 0.3 moles of hydrogen gas. Beautiful. So this is 0.3 moles of hydrogen gas will be what? Liberated. If 2 moles of aluminum yielded 3 moles from this equation, now we have gotten the moles as 0.2 moles according to the mass that was given. So this 0.2, what will it yield? What moles of hydrogen gas? What moles of hydrogen gas would be liberated? This is the relationship. Okay? So from this relationship, you have to cross and multiply and find the value of X. 0.2 times 3 divided by 2. Why are we dividing by 2? 2 times X. 2 is the coefficient of X. So by the time you make X the subject of the formula, 0.2 times 3 is 0.6. Are you with me? And when you divide by 2, you have 0.3 moles of hydrogen gas that was liberated. Now, this 0.3 moles of hydrogen gas that we have calculated, we'll now use it to answer the question, how many molecules? This number of molecules talks about the elementary particles, 6.023 exponent 23. How many number of molecules will this 0.3 moles of hydrogen gas contain? So, 1 mole is equals 6.02 exponent 23 molecules of hydrogen gas. Now, if 1 mole is this, what of 0.3 mole? That is the relationship. 0.3 mole will be equals to S. You simply do your simple cross and multiplication. So we'll have our x as 0.3 times 6.02 exponent 23. By the time you multiply this, exponent 23 molecules of hydrogen gas. So here comes the final answer. We have gotten the molecules of hydrogen gas that will be liberated from this equation, okay? That is the answer. Just navigate your ways and solve this. By the time you calculate for your moles, please do not end the equation here. The question is how many molecules of hydrogen? Like I said initially, you must calculate for the number of moles before you calculate for the number of electrons, the number of molecules, the number of particles. Are you with me? So for gaseous substance, you are calculating for the number of molecules, okay? So if 1 mole is equal to 6.023 exponent 23, 0.3 mole of this hydrogen will be 0.3 times 6.02 exponent 23. And that 1.807 exponent 23 is our final answer, okay? That is the answer. Alright, thank you for seeing this video. Please like, share, comment, give your thoughtful suggestion, okay? If you're yet to subscribe to this channel, please go ahead and do that. At the end of this tutorial, I usually post in the comment section the follow-up question. Do well to attempt it. Share with us so that we learn together, okay? This is K4, where we make chemistry fun and goodness each other. I'll see you right there in my next video. Bye-bye.